So the square root property states that if you can get an equation to look like x squared equals a number, if you can get it to look like that, then what you can do is you can then take the square root of both sides. So it'll look like this. And you'll just have x, because the square root of x squared is simply x. And that's going to equal the square roots of whatever number you had. And I say square roots because there's going to be two. There's going to be a positive square root and a negative square root. You can sort of simplify this by just writing plus or minus the square root of whatever number you had. It's a little weird seeing it there with the the number sign or the pound symbol, the hash symbol. So we'll just try it on one of these. But let me write down. This only works with equations that have no b term. Meaning that there's only the x squared term and the constant. Which you might notice is true of these four. There's only the x squared term. Maybe it has a coefficient in front, doesn't matter. But there is only the x squared term and then the constant. There's no, plus 5x or minus 17x in any of these. But in case that if that is the case, if there is only the x squared term and a constant term, you want to get it to look like this. You want to get it to where it's x squared equals a number. So how would we do that with the first one? Okay, yeah, add 49 on both sides. And you might be looking at example 1 and saying, okay, well that's a difference of two squares. Why can't we just factor it as x minus 7 and x plus 7, have it equal 0, and then solve each factor for 7 and negative 7? Well, the truth is that you can. We're just not learning that today. But, it's good to know multiple ways of dealing with the same thing. It's true in life, and it's true in math. Okay, so we have x squared equals this number 49. Well, x squared is the only thing on its side. 49 is the only thing on that side. If we take the square root, we should be able to get x equals. Okay, so that should just give us x equals 7, right? But not just 7. Yeah, well, no. The square root of 49, which is the number 7, but the plus or minus. And don't forget the plus or minus, because whenever you do the square root, so there are situations where, the square root is already in the problem, or it's already in the quadratic formula, and you'll notice it has a plus or minus in there too. And you don't have to worry about adding a plus or minus or anything. But whenever you do a square root as an operation, like here, you should definitely remember to put a plus or minus in the resulting step. Okay. Because the whole idea is that, we're looking for a number that if you squared it, we're looking for a number x, that if you squared it, you come out with positive 49. And while that is true of 7, it is also true of negative 7. You can take negative 7, square it, and come out with positive 49. And we don't want to lose that fact. So that's why we got to remember the plus or minus whenever we do the square root as an operation. But in each of these, we're looking to get this sort of variable squared equaling a number. Same thing with example 2. We want a variable squared on one side, an equal sign, and then a number. So how can I get that from what I have? Okay, so I'll subtract 19.
So x squared equals the square root of, or x squared equals 81.
81, which we can take the square root of, right?
So x equals plus or minus 9.
Yeah. I mean, so like this is, it's still possible to do this with factoring. For example, you could have subtracted 100 from both sides, gotten 8x squared minus 81, factor that into x plus 9, x minus 9. But, in some situations, something like this is faster than factoring a difference of two squares and setting each factor equal to 0. So ultimately, again, I want to end up with x squared equals some kind of number. What should be my first step? Well, and actually, it doesn't actually matter if you do the steps out of order in this one. But what should I probably do first? Okay, I'll subtract 40. Well, that's interesting. It'll equal a negative number. And this is something that factoring will not be able to take care of, because you're not thinking of imaginary numbers when you're thinking of your factors. Every time it's always just been positive or negative numbers. It's never been imaginary numbers that we've had to come up with when factoring. So this will take care of that. Okay, but then we'll divide by 2. So x squared equals negative 20. Or, well, let me put that in black. X squared equals negative 20. So there's a certain number that if we square it, we're going to come up with negative 20. This will probably be in some sort of imaginary number. But let's take the square root and find out. Okay, well, if you wanted to, as an intermediate step, you could just write x equals plus or minus the square root of negative 20, and then just sort of figure out how to simplify that later. But you can. So what is the square root of negative 20? Yeah, so you...
Wait,
okay.
Sorry. Yeah, 2 square root of 5.
Right, because you'll split it up into 4 and 5.
Right.
Yeah. So square root of 4, the square root of 5, and also I, because of that negative sign that's underneath the radical. So square root of 4 is the number 2. Square root of 5 is still under the radical. And,
So I guess we're going to be learning this later, right? Or wait.
Learning what later?
Or do we have to simplify? Wait, so we have to simplify the square root? If it's like that, we have to simplify it like that?
The square root of negative 20?
Uh-huh.
You can simplify it other ways.
Okay.
Like, you can... This is the only other way I know how, but you can do that thing, you can say this is 2 and 10. And 10 is 2 and 5. You can say, well, these are all prime, so I'm done. And then just say you're going to grab 2 of these, 2 square root of 5. And then don't forget your I.
Mm-hmm.
Yeah. So x equals... So 2 square root of 5 I. With that plus or minus in front of it. Okay, it's a similar deal with this last one. Example 4, we're going to subtract 60 on both sides. And we're going to end up with 5x squared equals negative 60, which we can then divide by 5 because we ultimately want to get x squared by itself, so that we can take the square root of both sides. But we get x squared is equal to negative 12. And we want to take the square root of that.
So x would equal 2 square root 3? Right?
Yes. Right. So you would split it up into 4 and the square root of 3. Yeah. You can write you can definitely write the factors in whatever order you want. So 2 square root of 3i.
And this is better than quadratic equations.
Or 2i square root of 3. However, whatever you like. Just don't forget the plus or minus. Okay.
Are we in college hour yet?
I think so. Yeah.
Okay.
Yeah. I mean, it's just sort of it's everywhere, It's not like it's
I'm trying to see if we transition, 'cause I don't know.
it's
how much further we
yeah.
go.
This is just an introduction. Don't worry about it.
Yeah.
You know what's funny is that they told you in school that you're always going to be math,
Uh-huh.
and no one believed them.
Mhm.
And then they go to college, and they have to do math.
Yeah.
It's like that thing that you realize that you
Yeah, I mean, I guess it depends on if they were talking about going to college or not. I mean, once you get out of college and you're actually in the real world, you might do math, you might not, depending.
Well, I can count my money.
Yeah. I mean, something similar. But we don't have. It looks like we don't have x squared like we did for the previous 4 problems. We have x minus 3 in parentheses squared, but it still works the same way. It doesn't matter whether it's x squared or some other variable expression squared. As long as the squared thing is isolated, it's fine. Okay, and it is here. So go ahead and take the square root. If we square root the expression x minus 3 squared, what are we going to have? Okay, right, that'll get rid of the square, and we'll just have x minus 3. And it's going to equal 8, but not just 8.
But why?
Plus or minus.
Hold on. So
Mhm.
why are we squaring that equation like that?
Or like, why are we square rooting it?
Yeah.
Because we want to eventually get x by itself, and we can't get x by itself if it's stuck in this parentheses with this exponent on it. We want to get rid of that
So
exponent.
how does square rooting it take the parentheses away and just make it x minus 3?
Oh, I mean, you can leave the parentheses if you want to. What it gets rid of specifically is the exponent of 2.
How does it do that? The square root cancels out the square.
Right, in the same way that,
Okay.
say, adding
I'm
3...
slow, y'all. Just bear with me.
In the same way that adding 3 and subtracting 3 one after the other, like they cancel each other out, or multiplying by 3 and then dividing by 3 will cancel each other out. Raising something to the second power, like taking a number, squaring it, and then taking the square root, that will undo each other. Okay. But yeah, we don't actually need the parentheses there. So, only one step left to get x by itself. We can actually add 3 now. Now that we're free from this exponent that's on the x minus 3, we can add 3 to both sides. And where I would recommend adding it is right before the plus or minus.
Oh.
So x equals 3 plus or minus 8. And you can actually take this further. Because you can actually, because these are whole numbers that you can work with, right? And 3 plus or minus 8 represents two solutions, 3 plus or 3 minus 8. If it's 3 plus 8, what is that? 11. Okay, so that's one solution. Oops. And if it's 3 minus 8, what is that? Negative 5. That's the other solution. If you want, you can, take 11 and negative 5, try them in the original equation. You'll find that they, that if you take 11, you subtract 3, and then you square it, you will get 64. Or if you take negative 5, you subtract 3, and you square it, you will also get 64. Okay. So in example 6, again, our squared term, our squared variable term, even if it's x minus 5 instead of a plain x in there, it is isolated. It is the only thing on its side. So we can take the square root of both sides. And if we take the square root of this x minus 5 that's being squared, what are we going to have on the left? Okay, x minus 5. Mm-hmm. 3 because the square root of 9 is just the number 3, and I because of the negative underneath that square root. Right. And by 3i, I actually mean plus or minus 3i. Now I'm just going to get x by itself by adding 5. I'm going to add a 5 in front of that plus or minus symbol. And x equals 5 plus or minus 3i. And in this case, unlike the last time, these are not like terms. 5 and 3i are not like terms. They can't be combined. So that just is what it is. If you want, you can write it as, a comma-separated list of two solutions, 5 plus 3i and 5 minus 3i. Or you can just write 5 plus or minus 3i. Okay. In example 7, is the squared variable isolated? No. There's that 28 on there. So the first thing that we're going to want to do is we're going to want to subtract 28 from each side. Okay, so that gives us y plus 4 in parentheses squared is equal to negative 28. And now it looks kind of like the previous two did. It's ready for it to be square rooted on both sides. That'll give us a plain y plus 4 on the left, and on the right, that'll give us plus or minus whatever the square root of negative 28 is. Right, we'll split up into 4 and 7. That's, we want to split up into one square number and like the biggest square factor we can find, and then whatever's left. And there's also going to be an I on there. Yeah, 2i the square root of 7, or 2 times the square root of 7 times I. And then just subtract 4 from both sides, inserting that negative 4. Alright, now these ones aren't going to be imaginary anymore, because they're not going to equal a negative number on the right-hand side. But still, we want the squared variable term to be isolated. So in example 8, what's the first thing we should probably do?
Add 4 to each side.
Right, add 4 to each side so that the squared variable term is the only thing on its side. So that's 2x plus 3 squared equal to 12. We can now take the square root of both sides freely. That'll give us 2x plus 3 just by itself on the left. And the square root of 12, I feel like we did that somewhere.
3 squared root of 2? Yeah. No. 4 and 3 and then... Oh, 2 square root of 2.
Right, right. So plus or minus the 2 square root of 3. Then we'll just sort of, get x by itself. This might actually take a few steps, but the first step still is to subtract 3. Subtract any other terms that aren't x. Or, get rid of any terms on the same side that aren't x. And so that'll give us negative 3 plus or minus 2 square root of 3. And we'll divide by 2. And make sure to divide the whole right side by 2. And that'll kind of make it look like something that came out of the quadratic formula. And this actually is the same solution that you would get from the quadratic formula if you were to, take this thing, expand it, and then, move the 8 over so that it's all, laid out nice. But, you probably don't want to be doing that. This is easier, but it is the same solution. As you would theoretically get. For example 9, start off by adding 8 to both sides. So we have 3 times this squared thing is equal to 24. Well, we can't actually distribute the 3. You can't distribute into something if it has an exponent on it. You could distribute the 3 if it was just like this. But this x plus 5, if it's being squared, it's not really x plus 5. It is... And don't write this down. X squared plus 10x plus 25. That is what you would technically be. That is what you would distribute the 3 into if you wanted to distribute the 3, which you do not in this case. You actually want still to get the squared variable term by itself, which 3 is not a part of. So we'll divide by 3. So we'll have x plus 5 all squared equaling 8. And we'll take the square root of both sides of that. Okay, that'll give us x plus 5 on the left, and plus or minus whatever the square root of 8 is. Why did I write 12 if it's 8? Okay. Yeah, but, right, you can split up into 4 and 2. So 2 square roots of 2. So plus or minus 2 square roots of 2, that's what we have on the right-hand side there.
So x would equal -5 plus or minus
Mm-hmm.
2 square root of 2.
Yeah. Just shove that -5 right in the front of that plus or minus there. So that's the square root property. It's all about, you know, if
That's
you...
okay, we can do this. This is good.
Right.
This is good.
Okay. That's good. Okay, but yeah, it's all about just getting whatever you have, whatever variable term you have squared by itself, equaling a number on the right-hand side. And for this reason, you can only do it when there's no middle term, when there's no b term. You know, there just has to be a constant and then like a variable squared. You get the variable squared on one side, you get all the constants on the other side, then you take the square root of both sides, remembering to do a plus or minus for when you're square rooting the number, and then just take any extra steps you need to get x by itself if you have to. Okay, now these, hold on, there's only 4 of these, there's 4 of these, okay. We can do that in 20 seconds. These look daunting, right? Because this is a higher degree of polynomial than you've seen so far. These are x to the 4th. You've only probably seen x to the 3rd at most up until now. That's okay though, because you're not going to be dealing with these in the usual way necessarily. We won't be using U substitution explicitly, because it's kind of a weird thing to think of. That's where you say, you know, like you would say U equals x squared, and then replace this with like U squared minus 10U plus 9 equals 0. But we'll just, you know, try to, yeah, make a detour that, you know, we don't have to pass directly through having to do a substitution. Okay. So it might look weird because of the x to the 4th and the x squared in the middle, but ultimately, does this or does this not look like a quadratic equation? Kind of.
Kind of.
Kind of. So in a quadratic equation, like, here, let's look at this for a second and then sort of compare x squared minus 10x plus 9. If we had that quadratic equation, right, and that's definitely a quadratic equation, how would we factor this? How would we factor x equals negative 10x plus 9? Right, we take plus 9. Or we wanted to multiply to positive 9 and add up to negative 10, so negative 9 and negative 1. Sorry. Negative 1. Okay. And what variable is in the front of each of our factors? X. X, because we need it to start off with an x squared, right? Okay. The numbers here are the same. You know, we still want them to add up to 9 and multiply to negative 10. So the numbers will still be minus 9 and minus 1. However, right, given that this equation starts off with an x to the 4th, what variable or variable expression, or power of x or whatever, do you think is going to be in the front of each of our factors this time? X squared, because x squared times x squared is what's going to give us that x to the 4th that we need. That's the only difference with these.
Okay, Mr. K.
There's a lot to remember.
If your equation starts with an x squared, your factors start with x and x. If your equation starts off with an x to the 4, your equations start off with x squared and x squared.
But where do you get -9 -1?
It's the same as it was for here.
So this is so many steps.
We'll make sure to we won't if it is we won't take the steps too fast. Now, there are two ways you could go from here. You could say, hey, x squared minus 9, that's a difference of two squares. So is x squared minus 1. You could separate each of these into their own two factors. That is one way that you could deal with this. You could say, okay, well, this is going to factor into x plus 3 and x minus 3, whereas x squared minus 1 will factor into x plus 1 and x minus 1. It all still equals 0. And then get your 4 solutions for x that way. It's going to be -3, +3, -1, and +1. The other way is you can actually set them equal to 0 from the way they are written here, now that you know the square root property. If x squared minus 9 equals 0, x squared equals 9. So what does x equal? What two things does x equal from that? Yeah. Right, and the other one is going to give you plus or minus 1. So that is also a possibility that you could do. You can set the whole x squared minus 1 factor equal to 0. Get x squared equals 1. Take the square root. And get x equals plus or minus 1. Or you can just, factor them as differences of two squares and, say, but now that you know the square root property, you have a different way of finding this than just plain old factoring the whole thing.
So what's the answer?
-3, +3, -1, and +1. I should probably limit myself to just one of the ways so that it doesn't get, crowded.
Yeah, I like the square root thing. Or okay.
Yeah. I mean, I'm going to rewrite it, but just beneath.
Gotcha.
Yeah.
I got confused.
Now, example 2. Just 6 minutes ago or something. Example 2. Let's pretend for a second that we're just dealing with something like x squared minus 5x plus 6 equals 0. What are two numbers that multiply to positive 6? Let's see. Yeah, it's got to be -2 and -3 because positive 6 and -1 will multiply to -6. And yeah, the whole number 6 deal with like it being 2 and 3 or like 6 and 1 and it being able to add up to 5 like in 2 different ways depending on the sign is a real it's not a nice number to be having. But it is -2 and -3.
So it would be x squared minus 2 and x squared minus 3?
Right. Because our factors are going to start off with x squared.
Because of the
X to the fourth,
power.
yeah.
Okay. You're getting it, Mr. K.
Yeah.
So then we do x squared minus 2
Equal to 0. Oh, it will just be the square root of 2. Plus or minus, actually. Plus or minus the square root of 2, but yeah, the square root of 2. Okay, so x equals plus or minus the square root of 2. Okay, and that's not something, and it's better that we know the square root property because, it is technically possible to factor these as differences of two squares if you're willing to do like x plus the square root of 2, x minus the square root of 2, but it's weird and, well, it's not weird, it's just less easy to recognize 2 as, it's less easy to think of 2 as like a square number, even though, in some way,
I like the
sometimes
square
you can.
thing better.
Yeah. Whereas on the other hand, x squared minus 3 is simply going to give you plus or minus the square root of 3. Okay, so there are 4 solutions: plus square root of 2, negative square root of 2, positive square root of 3, and negative square root of 3, which corresponds with there being an x to the 4th, right? That exponent of 4 means that there are going to be 4 solutions, or that 4 solutions are possible. Okay. -6. Okay. Okay. Now this doesn't look exactly like the others. There's
It's missing a number.
Yeah, there's no 3-term sort of setup. But if you think of this as being analogous to x squared minus 144, what would you do if you had x squared minus 44? Right, you would factor it as a difference of squares. You'd have one factor, you'd have another factor, you have the same numbers in the front and the back of each one would have a plus and one will have a minus. Okay, the same thing is going to happen here. Your factors are still going to start off with x squared as they have been. And in fact, x to the 4th is a square. It is x squared squared. That's how you get that 4. You know, you start off with x squared and you square it, you get that x to the 4th. So that is what's going to start off our factors. What number is going to be at the end of our factors?
12.
12, because of that 144, right? So it's kind of like you're square rooting this and square rooting this to deal with it being a difference of 2 squares. So 12 goes here, and 12 goes here. And one is a plus, and the other one is a minus. Oh, and it equals 0. So again, just like before, you're going to set each factor individually equal to 0. Subtract 12, subtract 12. So x squared is negative 12, which you'll square root. Yeah. So plus or minus 2 square root of 3i, or 2i square root of 3, whichever. But those are 2 of your solutions. And that comes from the fact that the square root of negative 12 is the square root of 4, the square root of 3, and I. Or 2 square root of 3, I. Okay, now the other one, x squared minus 12, if you set that to equal 0, you're going to add 12 to both sides. And you're going to get x squared equals 12, which if you square root that, yeah, you're going to end up with the same thing just without the I, because it's not negative 12, it's just 12. So x equals plus or minus 2 square root of 3. So those are your other 2 solutions. Okay. So just like when we're dealing with quadratic equations, we want to make sure that it equals 0. So what do we want to do on example 4? Subtract 6 from both sides. And you'll notice that gives us something pretty similar to what we had in example 2, just with a minus 6 instead of a plus 6. Well, let's see how that changes things. Okay. So this time, we do want it to multiply to negative 6 and yet add up to negative 5. What 2 numbers are going to do that? Yeah. Now we'll have the numbers negative 6 and positive 1. Yeah, so even just a small difference like wanting them to multiply to negative 6 instead of positive 6 can change what factors you're working with completely.
So x squared minus 6
Yeah.
and then x squared plus 1.
Yes.
And then you do the square root thingy.
Yeah. X should be the plus or minus the square root of 6. Okay, that's one set of solutions. If x squared plus 1 equals 0, that means x squared equals negative 1. Take the square root of that. Well, the square root of negative 1 is 1. So the square root of 1 is 1, and the negative gives an I, so x equals plus or minus I. You can write plus or minus 1i if you want to, but you don't have to. Only the I is really necessary. Well, those are your 4 solutions for that one.
So it's not a negative 1.
Yeah, I mean you can write
Okay, yeah.
yeah, you can write plus or minus 1i. That's also okay. Yeah. Let's learn about completing the square. And in case, you know, I don't do that great at it, I will tell you what the sort of like completed square, like I'll get you started on the one that says solve by completing this square on your homework. Okay. So for completing the square, you want to move the constant to the other side. Like to the opposite side as everything else. So in this case, we're going to subtract 1 from both sides. It's going to give us x squared minus 6x equals negative 1. And we're going to add to both sides a special number. And that special number is b, which you'll divide by 2 and square. So what is b, for example, in this problem? What's that? It's that negative 6 that's right there. So b is negative 6. If we divide it by 2, what do we get? Okay, negative 3.
Oh, what? Add a special number.
Yeah. So b is negative 6. If we divide it by 2, we'll get negative 3. And then if we square negative 3, what does that become? Right, positive 9. And that is the number that we're going to add to both sides. Yeah, so, right, so that it's considered the constant, like, if we're just sort of thinking about the left-hand side. So that'll be x squared minus 6x plus 9 equals, that negative 1's still there, but then plus 9, because we can't add something to the left-hand side without also adding it to the right-hand side. Okay. So that's x squared minus 6x plus 9 is equal to, what is negative 1 plus 9? Just 8, okay. Now this is something known as a perfect square trinomial. There is a very particular reason it was 9 that we added, and only 9 will work. Now you can either take this advice. It will always be the number after you divide but before you square. And you can say, okay, well, it's x minus 3, because that's the number after I divided by 2 but before I squared it. That's going to condense it into x minus 3 squared. Was that a good or a bad? Okay. Alternatively, you can just factor this the regular way. What are two numbers that multiply to 9 and add up to negative 6? Right, negative 3 and negative 3. So you can say this is x minus 3, and then say that this is x minus 3 squared. But then it just becomes like one of those square root property problems once you have it condensed down into where it's, this binomial squared equals a number.
So the green, when you highlight, that's the right answer, right? How you set it up?
There's the solution hasn't been found yet.
Oh, okay.
Okay.
I know, these papers don't be enough.
Solve using the square root property. So x minus 3 squared equals 8. Take the square root of both sides. That should give us x minus 3 is equal to the square root of, plus or minus, the square root of 8, which is going to be 2 square root of 2. And then just add 3 to both sides. This is a mess because I had to write words, but it'll just come out to 3 plus or minus 2 square root of 2. That's your two answers. Yeah, every quadratic so far has had two answers. And if you look at number 26 on the back, we'll talk more about, we'll do the rest of the examples tomorrow. But for example 26, I'll show it up there to where all you need to know is the square root property. But we'll finish the square. It's one.
That's a lot. My brain's fried. I'm gonna get oh, I'm going to. That helps you a lot.
Okay, so number 26 on the back. Okay, then I'll just put an image of this on Blackboard. Okay, so number 26, that is x squared minus 8x plus 6 is equal to 0. We first want to move the constant over to the other side. Okay, so that's going to be negative 8, but then divided by 2. Okay. Which is negative 4. Yes. So negative 8 divided by 2 is negative 4. And then negative 4 squared is 16. So 16 is, the number that we're going to add to both sides. Okay. So we're going to have x squared minus 8x plus 16 equals 10. If you factor this, two numbers that add up to 16 and multiply to negative 8, that's negative 4 and negative 4. And they're always going to be the same number with this because, the whole point is to write this as like a binomial squared. And you can't write a binomial squared if they're not the same binomial. Okay, So this is not the answer, but you can solve it from here with the square root property.
So we have to get the answer?
Yes, but the completing the square part has been done. Yeah.
Okay.
What?